Well, hello everyone. This is our last section. I'm calling this section applications. The beginning questions are more, here is a graph, can you read off all the relevant things like x and y intercept and end behavior and so on by looking at the graph. And then the second group of questions are scientific formulas that contain rational functions and how we can interpret them using the skills that we've already discovered. So the first one I'm going to do is just jump over to the homework and show you what it looks like. Right. Now, this fella here is clearly a rational function. Can you see it's got a horizontal and a vertical asymptote? So I'm going to call it a rational function. Now, from this, let's find the x-intercept. Well, the x-intercept is there, and that is, as you can quite clearly see, it's a coordinate they want, not 5, but they want the coordinates, which is 5, 0. There we go. I think I'll try and shrink this a little bit. That might make it a little bit harder to see the details, but at least you can see the question and the graph in the same place. Now, the y-intercept is here, and that's a coordinate, and that's at 0, 5. The vertical asymptote is this blue line, and if you count the little notches, you can see that it's a vertical line, and it's x equals 2, because all the points on that vertical asymptote have the same property that their x-coordinate is 2, and going across the way, we have a horizontal asymptote that is y equals 2. Now, they're asking us to describe the end behavior. Right, can you see that this guy here, as x gets really big and positive, it levels off at 2. And as x gets really big and negative, it also levels off at 2. And just to convince myself I haven't made any mistakes, let's do a submit answer on that. We're good. Now you can see in this question here, what are the x-intercepts, what are the y-intercepts? Vertical asymptotes, smaller value, which would be x equals -2. Do you see they've already put in the x equals for you? But if that was missing, you would have to type in x equals -2. The other vertical asymptote is x equals 4. Now, it does have a horizontal asymptote, and I'm making my best judgment call because it's not that clear, but I think it's going to level off on the x-axis, which is y equals 0. And I'm going to hit submit to see if I was right. And I said there's a vertical asymptote at x equals 4, and do you see why it said it was wrong? Have a look before I fix it. It already has the x equals. I just needed to fill in the 4. There we go. Everyone's happy now. Some others. These questions here are really just find horizontal and vertical, so there's nothing really to see here. Some more of the information, put together the features that I talked about and then get a graph, and it's one of those. Now, if you were talking about, I forgot to do this. How do you get the range? Well, you can only get the range after you've done the sketch. So let's just, for argument's sake, say that this picture here on the top right-hand corner is the correct graph. If it was, the domain would be everybody except x equals 2, where the vertical asymptote is. The range would be, well, that is the number 1. Any value of y above 1. But you notice it never actually reaches the horizontal asymptote. So it would be a curved bracket, 1, infinity. And some more sketches, I think. Do I have any? There we go, we have a slant one, right? Now, In this case, that's actually the one we did earlier, so you can check which picture it looks like. I think we've got that one. I believe it was this picture here. Here's another slant one that you would sketch. Here's a third slant one that you would sketch. Now, in this group of questions, which are now a part of what I would call the application ones, it says give an example of a rational function that has a vertical asymptote at x equals 9. Well, I can tell that it's that one. And you might say, but that one is also a candidate. If you plug them into your graphing calculator, that thing there actually simplifies down to the horizontal line 1. There are no vertical asymptotes. All it will have is at x equals 9, there's a hole in that horizontal line. Now, how about this one? Now give an example of one that has a vertical and a horizontal at 7. So you need to have both those things. So it could be that one and it could be that one, right? But it's only that one. And if you look carefully, you might be able to understand why the bottom one, because there's only one right answer, is the correct version. Look again at the bottom. You see the x minus 9s can cancel out, and that really just turns into a horizontal line, not a vertical asymptote. And same kind of thing with that one. And now we enter the last part, which are the true applications. So here we have a story and a formula. P of V, right? As a train moves towards an observer, see the picture. The pitch, so P is the pitch at a given velocity of a whistle sounds higher to the observer than it would if the train was at rest. So if you were like 100 yards down from a train and it was stationary and it was doing its whistle, that whistle would be a constant pitch. But as the train gets nearer to you and then passes where you are and then retreats away from you, I don't know if you've ever noticed it in movies or if you've ever been near a railway station where a train goes by you, it does change its pitch, right? The whistle, the sound it makes gets higher and then lower. And the formula for it is given as P naught, S of naught, S of naught, take away V. And I am now going to return the screen and add information to that. P of naught is the initial pitch of the train whistle. So if you had a whistle on a train that was very high pitched, that would be 2000. If it was a very low one, it might be 200. S naught is the speed, I'm assuming, of the train. They tell me its value is 332 over 332, again, take away V. So this is the equation that we're going to use for everything else that comes later. And the first question that they ask us, right, in this story is, what is the graph of that? Now, if you go into your calculator, which I'm going to do right now in Desmos, and plug this graph into it, we should be able to see what it looks like and then pick which picture looks the closest to it. So let's do that. P of V equals 410, bracket, 332 divided by 332, take away V. And I guess close the bracket. Wrong place. Close the bracket, right? That should work. So what's our problem? Let's just call it y equals in case Desmos gets confused. Oh, there it is. Whoa. That's a very weird shape. Obviously at 332, there's a problem, which I can now zoom in. And if I put the line x equals 332, we can see it. But basically, we're not talking about these big values. We're not even going to spend very much time on the low values, because the part of the curve that actually makes sense is I'm 300 feet away or meters away, I'm 200, I'm 100, I'm 0. And the model only really works for that value of x. So as we look at that, it basically looks like a curve going like that. So let's see what our choices are. Yeah, it looks like a curve going like that. So it's that one. Let's check it. Yep, little check marks down there, but it means that this is correct. Now, what is the vertical asymptote of the function? If you remember what we had in my picture, its vertical asymptote was actually at v equals 332. Oops. It is 332. Let's check. What did I do wrong? Oh, meters. Oh, come on. What's wrong? Okay, I'm trying to figure out what WebAssign is trying to tell me. Okay, it is 332. Let's check. It is 332. It is vertical asymptote. Hmm. It must be something I've not done. No, that isn't much help. I'm going to keep submitting this answer till I get it wrong, and it tells me the right answer. I think that's 5 guesses. Okay, what are you not doing here? What is me being silly? Okay, I can fix that. It is vertical asymptote, not horizontal asymptote. Horizontal asymptote is a different thing, it's one. It's horizontal asymptote is 410. No, okay. Well, I'm sure you've had this issue with WebAssign where you're 90% sure that you're right. So I can do a little cheat. I can go in and just do edit. And I'm going to find out what it thinks the answer to that question is. It's 332. I typed in 332. I did. Okay, so I was right all along, yet it never accepted it. That is kind of weird. Right, I'm going to go back in and try 332 one more time. I'll go in as a student. The problem with software is that it's pretty stupid. That is weird. I thought in all my choices that I put 332 down one of them. Evidently, I didn't. Okay. So, next one. A drug is administered to a patient. The formula for it, which tells you the concentration at given time t, is 8t over t squared plus 4. And it starts off by saying, what is the highest concentration of the drug that is reached in the patient's bloodstream? Now, to be able to answer that question, we really need to graph it and see what it looks like and find the highest y value, essentially. So let's kick into Desmos and do the concentration. C equals, I'm going to call it 8t divided by t squared plus 4. And looking at the scale, it's definitely not obvious what's going on. So I'm hitting shift and I'm making the vertical scale. Okay, I'm going to take the horizontal scale and I'm going to shift everything to the right. Do that. You don't want to think about what the graph looks like to the negative side because it doesn't make sense in the context of this model. You don't give person a drug 2 seconds before you've given them the drug, right? So you can't go back in time. At 0 is when the drug was administered. And I think it's pretty clear that the concentration is a maximum at 2. So let's go back and put in just 2 and no units and hope that I have a nice, friendly WebAssign. There we go. Now it says, what is happening to the drug after a long period of time? If I go back to Desmos, can you see that the drug is getting metabolized and basically getting used up in the body? So it's tending to 0, which means when it reaches 0, it will be all used up. It goes to 0. Now, how long does it take the concentration to drop below 0.5? I need to return to here, and I have to put in C equals 0.5. Is it C? No, it is C. What are you doing again? Okay, I'm going to make this Y, and then I'm going to make this Y. There we go. It's just a naming issue. Now, if you zoom in here, at that point there, while the drug is being pumped into the bloodstream, you see it reaches 0.5. And then way over here, on when it's being maximized and then being used up, it hits that 0.5 again at the same number. So I'm going to go back and see if they want this value the first time it reaches it, this value the second time it reaches 0.5, or whether it even wants both of them. So let's see. How long does it take the concentration to drop below? So the way they phrased it means 15.746. 15.746. Submit. Hopefully that is more than enough accuracy. There we go, we got it. Right, question 33 is pretty much the same as the one above. This one here is to do with a rabbit population, but what you're going to do is put this into Desmos and answer the graph, and then um, whatever is the final question. So that is the end of our last section. And bye-bye for now.